All right, hello everyone. Hope you are having a good day. Let's get started with today's lesson 523. When are they the same? By the way, before we get started, there is a handout in the packet for 523. It's not very complicated. It's just a plain, basic, full-page graph. It says 5.2.3 resource page. Please make sure you get that. I will include it on here as well, so you can print it out if you need to, but it should be in the packet. If not, if you don't have access to graph paper or to the handout, you can always just do a graph on graph paper, okay? So here we go, 523. When are they the same? Solving systems algebraically. Solving systems algebraically means using algebra methods that you've learned to solve equations. Solving systems that way. So far in section 5.2, you have solved systems of equations by graphing two lines and finding where they intersect, which is called, of course, the point of intersection. However, it is not always convenient nor accurate to solve by graphing. Today, you will explore a new way to approach solving a system of equations. Questions to ask yourself today include, how can I find a rule? How can you compare two rules? And how can you use what you know about solving? Now, just to make sure we're all on the same page, we are going to spend the first part of today, or basically this video, solving using tables and a graph. Now, this is the old-fashioned way, the way you learn how to do it, the way you've done it for a while, and we're just going to practice today, okay? So tomorrow we will work on the algebraic part. Use tables and a graph to find and check the solution to the problem below. Chubby bunny. Barbara had a bunny that weighs 5 pounds and gains 3 pounds per year. Her cat weighs 19 pounds and gains 1 pound per year. When will the bunny and cat weigh the same amount? Now, that is the question. I need you to make tables. Now, you could use tables, multiple tables, or one table, and we'll talk about that in just a second. And then a graph. See how it says tables, plural, and then a graph, meaning both will be on the same graph, okay? Whenever it says a graph for two different things, it means both on the same graph, okay? So what I want you to do is I want you to pause the video right now and just think about, how would I do that? What would the table look like? How would I solve the problem? If you think you can go ahead and make the table for this problem, you go for it. That's awesome. Don't work on the graph yet, but just if you think you got it, go ahead and do it. So you're going to pause the video and do that. If you are stuck, I will walk you through the process here in just a minute. But again, I really want you to try to do this on your own first, okay? All right, so go for it. All right, if you're listening to this now, it's because you are either already done with the graph and you're just verifying your work now, or you are kind of stuck at the beginning and you want some help. So here we go. Now, when it says tables, we are going to compare the cat and the bunny, right? Okay, and so we want how many years until they weigh the same amount? That's going to be some time. So I'm going to make a table. Now, you could make separate tables, like a table here for the bunny, and then another table over here for the cat. However, the one option that we have is to make a kind of combination of both. Okay, so to have to have one graph that includes both, and I'm going to try that. I'm going to cheat and have something that already kind of sets it up for me. And I'm just going to go with a series of problems tables like that. So I'm going to have X and Y. Now, the other thing we could do is, instead of putting X and Y, we could actually label with what it actually means. So what goes on top? What do we start with? I mean, we start with 0, 1, 2, 3, 4, 5, 6. Right, we start with that, but what does that mean? What are we talking about? Well, we're talking about the time passed. It's a time passed in years, technically in years, okay? I just don't have room to write that in. Time passed in years. And then the Y is going to be what? It's going to be the weight. Ooh, hold on though, I've got a problem here, don't I? That I can only put one of the actual animals on here. So I need a bigger table. I need to make my table a little bigger. And to do that, I'm going to try to highlight it. There we go. And I'm going to get rid of this. And I'm going to see about making a bigger table. All right. So let's try that again. So what if I go with 3? And then let's go a little farther. Let's try that. Okay. Now, again, I still am going to start. I'm going to start by. Come on. Sorry, my graph is going. My smartboard is. There we go. Cool. Up here, I'm going to have the years past, and this time I'll just put years past. And then here's going to be the weight of bunny. And then weight of cat. Now the cool thing about that is that allows me to put the weight of both animals on the same graph without doing a lot of extra work there. I mean, I've already just got to set it up. And you can do this on graph paper, you can do this on line paper, just take one line per animal. Now, and again, you can also work down if you wanted to. You could have made this table going down and said years here, and 0, whatever, down to like 9, and then the bunny here, and the cat here. Either way works for you. For me, for my space, it works better to go across, so that's what I'm gonna do. And then what we're gonna do is we're just gonna work on filling this out. Now, we see the bunny weighs 5 pounds and gains 3 pounds a year. So I want you to finish filling out this table. Oh, and sorry, and then the cat weighs 19 pounds and gains 1 pound per year. So finish the table. When you're done, come back here and let's compare our answers and see what you got. So pause the video and then fill it out and then unpause it when you're ready, and I'm gonna fill it out here too. Okay, now here's a big catch right here. Year 0 would be 5, and then after that you start gaining 3 pounds. That's horrible. After that, you start gaining 3 pounds, so then we get to 8, and then 11, and 14, because it's gaining 3 pounds every year, okay? Holy cow, a 32-pound bunny would be huge, wouldn't it? Okay? I don't know, do bunnies get that big? I'm not sure. I know cats can get pretty big. Well, then the cat starts at 19, but just gains 1 pound every year. So I just start putting in my numbers. Cool. Now that is my data there. I'm looking for when will the bunny and cat weigh the same amount? That means at what year will the numbers be the same for both of them? And if you look at your table, analyze your table, did you find your answer? Yes, right here, year 7, both the cat and the bunny will weigh 26 pounds. 26 pounds, that's insane, okay? All right, now we did the table, now you're gonna do the graph, okay? You're gonna do the graph. And so what I want you to do is on your paper, you have a handout, on that handout, I'm sorry, that handout is going to, you're gonna make your table there, or I'm sorry, you're gonna graph both the bunny and the cat on that handout, okay? Now I have done that work. I've got it here. I want you to check it. I want you to try it first though. Do the table, do the graph. When you're done, I am going to show you. So I want you to pause it. I want you to do it. When you're done, I want to show you the answer. And hopefully you did it on your own. Your graph may not look exactly like mine, and that's okay, but it should be accurate, okay? So pause the video, make the graph. When you're done with the graph, unpause it. Okay, so here we go. Ready? What should your work look like? It should look like, ready? Boom, just like that. Now, we've got, I do want to point out, here's my table, and this one's going down. Some of you prefer it this way. Maybe you set up your table like this. And then when you get to your graph, now here's the big thing. Some of you are always confused as to what goes on the x-axis and what goes on the y-axis. And I need you to quit being freaking out about that. What I want you to think about is, think about your table. You very easily put these numbers down, right? You just knew, hey, we'll just put the number of years here, and then we're going to find the weight of the bunny. The numbers you start with, the numbers you automatically put, always go down on the x-axis because they are independent. They do not depend on anything. We couldn't find these numbers until we had these numbers here. So these numbers here, the weight depends on the number of years, which means those are the dependent variables. Okay, so this is what your graph should look like. However, I'm not going to finish answering this. Here's what I want you to do. Should I, let me put it this way. Should this be a continuous or discrete graph? okay? Continuous or discrete, and why? Should it be continuous or discrete, and why? So by tomorrow, when you come to this class, you do need to bring this. I expect to see this table or this graph completed, okay? Now, if you were able to do it on your own, it doesn't have to look exactly like this, but if you got stuck or if you did it wrong, you need to erase it and you need to fix it. You can quote unquote copy off me if you wanted to, although that doesn't help you as much, but your graph should look pretty much like this. When we come to class tomorrow, we will be discussing, I want you to all show me, everyone's gonna show me their graph. Those of you at home are gonna show me on your camera or upload a picture of it. Those of you in class, you are gonna show me personally your graph. And then you're gonna tell me if it should be discrete or continuous. Got it? All right, that should be it for today. Have a great day and I'll see you tomorrow.